slide here some facts. Number one, the distinction between explanatory and response variables is essential in regression. If you reverse the roles, you're going to get a different line. So you have to make sure you pick the correct explanatory and response. Number two, there's a connection between the correlation and the slope. If your correlation is positive, your slope is positive. If your correlation is negative, then your slope is negative. That's the relationship between those. It doesn't mean they're the same. So like if your correlation is 0.7, that does not mean your slope is 0.7. It just means your slope is positive. Okay, so they're not the same number, just the same direction. And number three, the least squares regression line will always go through the point x bar, y bar. Remember that this point we talked about on the previous slide. This point is the mean of your two lists. X bar is the mean of list 1. Y bar is the mean of list 2. The regression line always goes through the mean. Always. That probably will be a test question.
So what goes through mean?
Example. In this example it says we have an equation here that's our least squares regression line called y hat for the sprint time and long jump distances. I think we talked about this earlier, didn't we? Like yesterday? Find and interpret the residual for a student who had a sprint time of 8.1 seconds. And we'll go back to page 2 of our notes in just a moment. Let's calculate the y hat. So y hat y hat would be equal to 304.56 minus 27.63 times the 8.1. That's the data point that they gave us. This gives me a total of 80.76. So you can check my math there. From the previous slides way back when in our table, if you go back in chapter 3 notes, you will see that for somebody who was 8.1 seconds in sprint time, the long distance jump was 151. So our original point looked like this, 8.1, 151. This is from the table. That means that this thing is the actual distance. So if we want to find our residual, what we will do is we will take the actual distance, which was 151, and we will subtract off 80.76. So the residual is 70.24. This is the residual. What does this mean? This means the student jumped. Oh, was this in what was this? Was it in feet, meters?
It was inches.
Inches jumped 70.24 inches farther than expected. Because remember, your regression line is what would you expect? What would you predict? So instead of using the word expected, you could use the word predict. Okay, second example. The number of miles in thousands for 11 used Honda CR-Vs have a mean of 50.5. So this mean that I'm looking at right here, I would be calling X bar. And then it has a standard deviation of 19.3, which I'm going to call SX. Son of a gun. And Sam, you are right, it is SX. And then the next thing that they talk about is the advertised prices had a mean of 14,425. So I'm going to call that Y bar. And then the last thing that they talk about is the standard deviation of $1,899. So that's going to be SY. In part A, we want to find the equation to the least squares regression line. And in order to do that, we need two parts. We need the A and we need the B. Which one do we have to find first?
B.
The B, very good. We got to find the B first. So the B, when we're finding it, we know is equal to R times S.
Y over SX.
Thank you. SY over SX. So in our particular case, they tell us that the correlation coefficient is here. So I write that down. Is that a negative?
Yeah.
Negative 0.874 times SY, which was 1899, divided by
50 point. Oh, just kidding. Sorry.
19.3.
19.3. Or in other words, when I calculate that, I hope I get negative 86 roughly. Somebody check that, please. So now we have to find one more thing. We have to find A. If we're going to find A, our A value was equal to
Y mean minus B.
Y mean minus B X mean.
Yep.
Okay. So in this case, the Y bar was 14,425. The B we just got done with, that's negative 86. And the X bar was 50.5. When I calculate my A, I think I get 18,768. What this tells me is that if I'm looking for my equation, I'm going to actually write it under the B right now because I'm running out of room. But if I write down my equation, I get that my Y hat is going to be equal to negative 86x, because negative 86 was my slope, and then plus 18,768, which was my y-intercept after calculating because it goes through the mean. Okay, so when you answer a question, it's extremely important, Madeline, to read carefully. In part B, it says, what change in price would you expect for each additional 10,000 miles? And back up in the beginning, these were the number of miles in thousands. So if I want to know the change in price for each additional 10,000 miles, what I would do then is I would say it's going to be the slope change, which is negative 86, but this is for every 1,000 miles. So I multiply that by 10, and you get negative 860. Or in other words, the price drops $860 for each additional 10,000 miles, the K representing 1,000. So for our next example, you'll see that Mr. Bartz does an experiment with his Hot Wheels car, and he wants to